Hi, welcome again to a new tutorial. In this tutorial we interface the 8051 to a computer or other devices. Let's talk about the serial port. Compared to parallel communication, serial communication requires lesser wire and can go further. Ubiquitous data is sent bit by bit, while in parallel each bit is a wire. In serial communication, data can be sent by synchronous or asynchronous modes. In the 8051 microcontroller we have a built-in hardware asynchronous serial controller, or a hardware UART. Universal Asynchronous Receiver Transmitter. Data sent is in asynchronous mode is sent through a start bit which is always low, then a data packet is sent usually 8 bits, but can be 5 to 9 bits, then followed by a stop bit which is always high. Aside from the data format, we must also know the transmission rate. It is how fast data is pumped out of the microcontroller. It is measured in bits per second. There are standard baud rates used like in older modems which uses 1200 baud, but in interfacing, we usually use 9600 baud. If you need speed, then pump up to 115,200 baud. In determining the transmission rate, the crystal frequency is a very important consideration since it is the input clock to the timers which will generate the baud rate. Now when it comes to the hardware standard, older PC that has serial port uses the RS-232 standard, while modern PC don't have this anymore. The RS-232 has different voltage level, thus a line driver is required when connecting the microcontroller to the computer. MAX232 is the most commonly used line driver. We only need 3 lines: transmit, receive, and ground. The transmit of the microcontroller is connected to the receive pin of the computer, and the received pin of the microcontroller is connected to the transmit pin of the computer. With modern computers, we use USB to serial converters. These converters are TTL, same as with the microcontroller, and it can be directly connected without any line drivers. With modern devices such as mobile phones, we could interface the microcontroller by connecting Bluetooth modules to the UART or other wireless modules, such as XB or ISM band RF modules. It can also be used to interface with GSM modules or Wi-Fi modules for IoT projects. Let's move on how to program the 8051 serial port. Aside from timer 1 register, we have the SCON and SBUF registers. The SBUF register will hold the data to be transmitted and received, while the SCON register is where we set the modes and also contains interrupt flags for the serial port. To meet the standard of baud rates, we choose a crystal frequency that can give us exact numbers to produce the baud rate. For example, a 11.0592 MHz clock will give us an exact 28,800 Hz to produce 9600 baud. After it is divided into 12 cycles, then after it is divided by 32 by the baud rate generator, non-exact values will lead to clock slippage, resulting to corrupt data transmitted and received. Let's take a look at the code. First we set up serial port by setting timer 1 to 8-bit auto reload mode and load the value computed for 9600 baud to TH1 and start timer 1. Then we set SCON to mode 1 and enable receiver. We are going to use the interrupt for receiving data, so we enable it. Next, to transmit a character, we load it to the SBUF register and wait until the transmission is done by pulling TI flag, then we clear the TI flag. To transmit a string of characters, we just send it one by one using for loop. Inside the serial port interrupt routine, if a character is received, we disable first the interrupt and load the contents of the SBUF to the global variable RX. We disable the interrupt to prevent data collision, then we clear the received serial interrupt and re-enable global interrupts. To demonstrate, we send a message to the computer when a switch is pressed, then we toggle a LED when the A character is received from the computer, as can be seen in our main program. Let's see it in actual. We loaded our compiled hex to our board and connected USB to serial adapter to our board. It will be detected as a COM port in your computer. To test, we use a terminal program such as PuTTY. When you open, enter the COM port number of the USB to serial to PuTTY. As you can see, a string is received by the computer, and if we press the A on the keyboard, we toggle the LED and send a string.